So let's imagine this. You've got a 4K broadcast of a football game, right? It's happening live in a stadium. And you need that exact perfect signal in a control room, say 30 kilometers away.
That's a long way.
It's a really long way. You can't just run a normal copper cable. The signal will just be noise by the time it got there. So how do you do it? How do you move all that data instantly without losing anything?
Well, you have to abandon electricity. You have to turn it into light.
And that's exactly what we're digging into today. We're looking at the Thor.
Right.
F-RF-Tx-MN-2mW-1550.
It's not a catchy name.
Not at all.
Yeah.
It's a completely unsexy name for a little box that solves a huge problem, distance. We got the tech specs here from HDTVSupply, and what it boils down to is taking old school cable TV signals and, well, shooting them down a piece of glass.
Right. It's a bridge. We're in this kind of in-between era where we have all this legacy coax cables, RF signals, standard digital TV, but we need the speed and the reach of fiber optics. This device sits right there at that intersection. It takes analog, digital QAM or ATSC signals and just converts them.
And the range is really the headline here. We're not talking about connecting two rooms in a house. The specs say this can push a signal from 5 kilometers all the way up to 30.
That's a serious commute for a piece of data.
It really is.
And to make a trip that long, you can't just use like a generic laser pointer. You need a very specific kind of engine. This one uses what's called a high-performance DFB coaxial laser.
Okay, let's pause right there. DFB. The spec sheet really highlights this. Why does that matter? What is that?
DFB stands for distributed feedback. Think of a normal laser like a choir singing a note. It's loud, it works, but you get these tiny variations in pitch from all the different voices.
Okay.
A DFB laser is more like a single, perfectly synthesized electronic tone. It operates at one specific wavelength, 1310 nanometers in this case, and it's incredibly pure.
So it's about focus then?
Exactly. It's all about that purity. That's the only way you can maintain the signal's integrity over 30 kilometers. If you use that choir laser, the signal would just drift and degrade. This keeps the RF power stable across the whole bandwidth.
But I'm guessing that keeping a laser that precise isn't a set it and forget it kind of deal. The docs here mention advanced CPU processing. Is that just marketing talk?
No, not at all. Think of the CPU as the pilot, keeping the plane steady. It's a microcomputer that is constantly monitoring the control system.
Just watching the laser.
It's watching the laser, making sure it doesn't get overdriven. That auto-monitoring is what guarantees the performance, and frankly, it's what makes the hardware last so long.
Okay, but this high performance seems to come with a catch. I'm looking at the important note in the specs about the connectors.
Yes.
Now, usually I see a fiber port, I grab a standard SC cable, I jam it in, done.
If you do that with this unit, you will kill the signal. Dead. This is the thing with such a precise DFB laser. It is incredibly sensitive to back reflection. You have to, and I mean must, use an SKC connector.
And that's the angle polished one, right? The green one.
Correct. The very tip of the fiber is polished at an 8-degree angle. A standard flat connector is like a perfect mirror. Light hits it, and some of it bounces straight back into the laser.
And that messes everything up.
It completely confuses the laser, ruins the signal. The angle polished connector is like a slanted window. Any reflection bounces away from the source. It keeps the signal clean.
So if your whole building is wired with the standard flat connectors, you're just out of luck.
No, you just need an optical jumper, a little patch cable to convert it.
Yeah.
But you cannot skip that step.
Wow. It's amazing how much engineering goes into just keeping the thing from, blinding itself.
Pretty much.
Okay, so practically speaking, does all this tech draw a ton of power?
Surprisingly, no. It's a low-power loss design, less than 8 watts. It runs on a simple 12-volt DC supply, which helps keep the temperature down. And heat is always the enemy.
Right. So that efficiency feeds right back into reliability.
Exactly.
I did notice the price point is around, $2,500? That definitely tells me this isn't for the hobbyist trying to wire up their garage.
No, definitely not. At that price, you're not just buying a metal box. You're buying the guarantee that the signal at kilometer 29 looks identical to how it looked at kilometer 1.
It's professional infrastructure.
That's what it is.
So when we step back from all this, what's the big takeaway?
I think it's a reminder of the invisible backbone of all our modern communication. We click a button and we just expect video to show up instantly.
Yeah, we take it for granted.